For most of human history, life moved at the pace of nature, slow, deliberate, and limited by our own minds and hands. Information traveled no faster than a horse or a ship, and knowledge was fragile, stored in memories or painstakingly copied books. Calculations were manual, tedious, and error-prone, counted on fingers, stones, or scratched into clay. A merchant's tally or a scholar's search could take hours, days, or even months. Communication across distances was a monumental effort, with letters crossing mountains and seas, their arrival uncertain. The world was immense, and our understanding was limited by the speed of our own minds. The great works of antiquity, pyramids, aqueducts, cathedrals, were built on endless, repetitive calculations, each mistake a potential disaster. The human brain was the only processor, magnificent but fallible. The need for a tool to amplify our minds was ever present, a quiet hum beneath civilization. How could we count faster, store information more reliably, and free our minds for greater discoveries? The answers would emerge slowly, over centuries, from unexpected places. This is the story of how our need to count and remember would lead to a machine that would reshape our world. The journey began with simple, ingenious tools like the abacus, a frame of beads that let merchants calculate with speed and accuracy. Across the world, different cultures invented their own methods. The Inca quipu, a system of knotted strings, stored census data and resources. The quipu was a physical database, a library of information encoded in knots. In ancient Greece, the Antikythera mechanism, a complex assembly of gears, predicted the movements of the sun, moon, and planets. These devices were analog, representing numbers through beads, knots, or gears. They were the ancestors of the modern computer, mirroring the mind's processes in the physical world. The abacus, quipu, and Antikythera mechanism all show a universal human need to record, remember, and manage complexity. They established a principle: the abstract work of the mind could be mirrored in objects. These were the first whispers of a revolution. The dream of a machine to amplify our minds is ancient. These inventions were not just tools, they were the seeds of something far greater. Humanity was on the verge of creating a tool that would change everything. The revolution had begun quietly, bead by bead, knot by knot. The next leap came in the 19th century with Charles Babbage. Frustrated by errors in hand-calculated tables, Babbage dreamed of a machine to automate calculation. His difference engine proved the concept, but his true vision was the analytical engine, a general-purpose computer. It had all the essentials: a mill for calculation, a store for memory, punched cards for input, and a printer for output. Babbage's design was a century ahead of its time. Working with him was Ada Lovelace, who saw that the machine could manipulate not just numbers but any information. She wrote the world's first computer program, glimpsing the creative potential of the computer. The analytical engine was never built in their lifetimes, but the blueprint for the digital age was drawn. The idea of a programmable machine was no longer fantasy. The theoretical foundations of computing were laid. The dream waited for technology to catch up. Babbage and Lovelace's vision would shape the future. The age of the programmable machine had begun. The 20th century brought war and urgency, and with it, the shift from gears to electricity. At Bletchley Park, Alan Turing and his team built Colossus, one of the first programmable electronic computers to break enemy codes. Colossus used vacuum tubes to process binary code, filling entire rooms but working at unprecedented speed. In the US, ENIAC was even larger, with nearly 18,000 vacuum tubes and the power to perform calculations 1,000 times faster than any human. Programming these giants was laborious, and the machines were unreliable, hot, and expensive. Only governments and research institutions could afford them. These computers were the dinosaurs of the digital world, impressive but destined for extinction. They proved electronic computation was possible, but a new kind of switch was needed. The revolution was waiting for something smaller, faster, and more reliable. The age of the giants was just the beginning. The next breakthrough would shrink the computer and change everything. The future of computing was about to get much smaller. The electronic age was ready for its next act. The breakthrough came in 1947 at Bell Labs, the transistor. Small, reliable, and cool-running, the transistor replaced bulky vacuum tubes and sparked the modern electronics revolution. Computers built with transistors were smaller, faster, and far more reliable. The idea of a computer in an office, not a building, became real. The next leap was the integrated circuit, or microchip, invented by Jack Kilby and Robert Noyce. Microchips etched thousands of components onto a single sliver of silicon, shrinking computers even further. Moore's law predicted the number of transistors on a chip would double every 2 years, driving exponential growth. The microchip made computers cheaper, smaller, and more powerful. The mainframe era gave way to new possibilities. The tiny switch had become a city of switches all working together. The stage was set for the personal revolution. The computer was ready to leave the lab and enter everyday life. As microchips grew more powerful and affordable, computers left the exclusive realm of corporations and universities. The microprocessor put an entire CPU on a single chip, making personal computers possible. In the 1970s, hobbyists and entrepreneurs built the first home computers in garages. Steve Jobs and Steve Wozniak's Apple II brought computing to the masses, friendly, colorful, and approachable. The IBM PC set a standard, creating a vast ecosystem of compatible machines and driving prices down. Software companies like Microsoft made computers useful for everyday tasks, writing, calculating, and playing games. The personal computer transformed work, created new industries, and changed home life. For the first time, ordinary people had access to immense intellectual power. The computer became a personal companion, sitting on a desk, waiting for the next command. The revolution was about empowerment, not just calculation. The computer was no longer a distant giant, it was part of daily life. The world was ready for the next connection. The stage was set for a global network. The next leap was connecting computers together, the birth of the internet. ARPANET, a US government project, pioneered packet switching, creating a decentralized, resilient network. For years, the internet was used by researchers and the military, accessible only to experts. The explosion came with Tim Berners-Lee's World Wide Web URLs, HTTP and HTML, made the internet easy to navigate. The first web browsers opened a clickable, graphical universe to anyone with a mouse. The internet burst into public consciousness in the 1990s as companies and individuals rushed online. Email, websites, and online communities connected people across the globe. The personal computer became a window onto the world. The internet became the nervous system of the digital revolution. Information, communication, and collaboration were transformed. The world was more connected than ever before. The digital age had truly arrived, the next step putting the world in our pockets. The story of the computer is one of shrinking until it fit in our hands. Early PDAs and mobile phones hinted at the future, but the real breakthrough was the iPhone in 2007. Steve Jobs introduced a device that combined phone, camera, music, and internet in one elegant package. The smartphone era began, soon joined by Android devices. The computer was no longer a destination, it was a constant companion, always on and always connected. We navigate, communicate, capture and access information from anywhere, anytime. Smartphones and tablets changed daily life, weaving computing into everything we do. The world's knowledge is now in our pockets, a few taps away. Computing became personal, pervasive and indispensable. The journey from abacus to smartphone was complete. The tool to aid the mind is now always with us. Today, the computer is not just a device, it's the invisible infrastructure of modern life. It runs our cars, homes, hospitals, farms, power grids, and financial markets. Computing has accelerated discovery, connected humanity, and created new opportunities for creativity and prosperity. Code has built a new digital reality layered over the physical world. We live as much in the digital realm as the analog one. But this transformation brings challenges, privacy and security, digital divides, and the rise of artificial intelligence. The story of the computer is a human story of curiosity and ingenuity and the relentless drive to understand and shape our world. From abacus beads to trillions of transistors, the journey is a testament to the power of the mind. The tool we created now shapes us in return. The future is unwritten, but the computer will be at its heart. The story continues generation after generation.